Testing, testing, microphone. Welcome back, students. This is the first time through this particular medium for our lesson, so there might be a few challenges. So I would like to just speak to you a little bit about an overview of that. I've tried to make this online experience as similar as possible to what was previously done in the classroom. At the advice of people much more tech savvy than I, we've chosen this particular method to give online lectures. This medium will allow me to continually show the PowerPoint slide and also give me the ability to speak and write directly below the slide, similar to what was previously written on the whiteboard. If you have questions, we'll communicate via email. It would also be important if you do email me to clearly identify what lesson you are referring to and what slide you have a question on. This will prevent a lot of email tag and be much more efficient. I have about 115 students, so this will be pretty important. There is a number of advantages to this medium. First advantage is that anytime you can pause the video or rewind and run a portion or all of it over again. Obviously, this would be good to be familiar with that. At the end of the video, you will be given an assignment to complete. Take a good and readable picture on your phone of that completed assignment and send it to the corresponding Dropbox in Blackboard. A second advantage will be the Dropbox for each assignment will be open for 2 class period days after the corresponding video for that section. So rather than having the assignment due the next class period, you would have 2 class periods to get it done and turn it in. If you turn it in after the second class period day, you would be deducted for having it late. A final advantage will be you will not have to watch the video during what would have been the scheduled time of the class. This would certainly be a big advantage for those living in the Pacific time zone. Otherwise, they would have needed to listen to the video at possibly 6 a.m. each day the class met. Each day the class is supposed to meet, I will be sending you our URL address, which will be sent to a link from the cloud where you can access the video. If you go onto Blackboard, you'll see it listed as a video. If you click on it, you can run the video at your disposal or at your time frame. We are told using the cloud reduces the chances of overloading a bandwidth or causing a crash or freeze. You will need to stay fairly current as the link will not be open indefinitely. I usually will allow the video length to be open about 1 week. So please do not procrastinate as the availability of the link will run out eventually. It is important you realize we're still in session as a college, even though we've given more freedom when you do exactly the work you've been asked. So stay current as best you can. We will cross the procedure for testing at a later date. I would like to review here first by looking at the empirical rule. We looked at this right before we left, and we said on the empirical rule that for a normal distribution only, that would be one that is bell-shaped, there will be a mean right in the center. Then we have about 3 standard deviations each way to get very close to the edge. If I go 1 standard deviation each way, in other words, this particular interval, it has approximately 68.26. We've been rounding that off to just 68%. That would mean that there would be 34% on the right side of the mean and 34% on the left side. If I were to go to 2 standard deviations each way, 1, 2, that interval will contain 95% of the scores. We've been rounding that off to 95%, which means this half between my fingers would be half of 95 or 47.5, and this half between my fingers would also be 47.5%. If we go 3 each way, we get almost all of it, 99.7. There's always going to be a few outliers out there, but usually we'll oftentimes consider that to be almost 100%. Those percentages are quite exact for a total normal distribution. It's referred to as the empirical rule. I want to emphasize again, only works with a normal distribution. We've done a few of these, so this will not be, again, new to you, but just kind of background of where we're going today. This particular one, I've been given that a mean is 80, the standard deviation is 5, and normal distribution. Normal distribution is quite important here because that means I can use that empirical rule that we just got done reviewing. The mean is 80, that's the middle value. I typically put the standard deviation up here as 5. As we mentioned earlier, 3 standard deviations takes you just about to each edge. Because the standard deviation is 5, that means that first one is at a score of 85, 90, and 95. This one would be 75, 70, and 65. For this first one, number 1, we want the percent of scores that lie below 80. So I would be looking at all of these scores. Because this is right in the middle, this would be 50%. So the answer to the first one would be 50%. What percent of scores would lie below 75? Well, 75 is going to be from right here on down. In other words, all of those. You remember 1 each way was 68%. So half of 68, or 34%, would be in here. Because it's 50% for the entire half, this unshaded part is 34. This shaded portion would be 50% minus 34%, which would be 16%. So my answer for this one would be 16%. Let's take just a few more once as well. Let's take number 5 next. We want the percent of scores that lie below 85. This is what I mean by drawing the picture every time. I'm going to draw that normal bell, putting in at least the dash marks, even if I don't put all the numbers there. I put the 80 in. A number 5 has 85. Because the standard deviation is 5, that's the next tick mark over. I'm looking for all of that particular percentage. This was half of 68, or 34%. This is an entire half, or 50%. I am looking for all of that, so I'm going to be adding those together. 50 and 34 make 84%. And that would be the answer to that one there. Knowing how to do these, and we've done them before, so this is review, is pretty important for us. There's 2 types of problems that we typically encounter with this. I'm going to do those once right now. The first one is where we ask for a probability, or we can think of that P as a percentage of X's that are greater than 44. This particular normal distribution has a mean of 60. So I'm going to draw the picture again. And it's got a standard deviation of 8. That means this would be 68 here, 76, and 84. This would be 52. 8 down would be 44. 8 more down would be 36. We're looking for the percentage of scores that are greater than 44. That would mean from 44 to the right. I'm basically looking for all of that shaded portion. This one was 2 standard deviations over. You remember if you went from 2 to 2, that was 95%. This would just be half of 95, or 47.5%. That would be all of that shaded portion. Then this is an entire half if I'm going greater than 44, so that means 50%. So from the 44 all the way would be 47.5 plus 50, which would give us 97.5% of the scores. That was one of the 2 types. That was a type where we were asked to find the percentage. So my answer was a percentage. I could have listed it as a decimal, and that would have been fine. When they list it as a decimal, they frequently let the P refer to probability. If they want it as a percentage, they're thinking of the P as a percentage. I would accept either one of these on the test. But now a second type. We haven't done this type yet. Okay? I'm looking for finding the score that is above 68.26% of all the scores. I apologize. I'm going to change that percentage once here. Rather than writing it that way, I have a misprint there. I'm going to think of it as 84% above all the scores. So I'm changing that problem. There was a typo in there. Okay. This is the second type. I'm looking for a score now rather than a percentage. What that means, going back to the old drawing, the scores are these numbers down here. So I'm looking for one of those types of numbers rather than a percentage. I draw my picture again. The middle value is the mean of 60. The standard deviation is still 8. I'm looking for the score that is above 84%. Okay, well, above it means I need 84% has to be below. Keep in mind this entire half is 50%. I need it to be above 84. The difference between 84 and 50 is 34%. So I need another 34% over here. This score would be above those 2 together, which would be above 84%. That score is determined by the empirical rule again, which meant 68% from 1 to 1. Half of that was 34 on each side. So I'm looking at 1 standard deviation over. 1 over from 8, 1 8 over from 60 is going to be 68. That score was found by taking the mean 60, adding to it 1 of our 8s, 1 of our standard deviations. So doing this second type, one formula that you will be working with will be this formula. The score is equal to the mean, which in this case was 60, plus or minus, this won't make sense just yet, we'll get there today, a z-score times the standard deviation. this z-score will be like 1 standard deviation, or maybe 2, or maybe a -2 or something like that. But copy this formula down. I'll be coming back to it later on. The mean plus or minus a z-score, which we haven't done yet, we'll get there, times the standard deviation. That standard deviation in this problem was 8. The mean in this problem was 60. The z's we haven't covered yet. The z distribution transforms every standard deviation into the value of 1 unit. That may not make a lot of sense just yet. It also then forces every mean to have a z value of 0. I'll cover that twice over. It looks like this. The mean, the bottom here is the z-score, 0. When you go over 1 tick mark, 1 standard deviation, the z-score that corresponds to that one is 1. If I go over 2 standard deviations, the z-score would be 2. If I go over 3 standard deviations, it would be 3. Notice then the z-score, these numbers, are describing how many standard deviations we go over. If we go to the left, we make our z-score negative. So 1 standard deviation to the left would be a -1. 2 standard deviations would be a -2. And of course, 3 would be a -3. That z distribution, you saw this slide a moment ago, transforms every standard deviation into the value of 1 unit. So these are all 1 unit apart, 1 unit apart. This is another drawing of the same thing. Notice this is using the sample mean symbol, x bar. It is no different than mu, which we had on the previous slide. Mu refers to the population average. This would be a sample average. But now notice I have 1, that's the symbol for standard deviation again. 1 standard deviation to the right, 2 standard deviations, 3 standard deviations, etc. This would be -1 standard deviation, which is why we had a negative there. 2 to the left would mean I'm subtracting, or -2 standard deviations. This one also gives me the percentages, 34 in each. This column is 13.6 and 13.6. We'll deal a little bit more with that in a moment. This normal z distribution, so far we've looked at 1s and 2s, 3s, etc. This allows charts to be made for all normal distributions, no matter what the mean or the standard deviation was. It's also why they can program that chart into your calculators and computers. It also demands we convert every mean to 0 and our standard deviations into a z-score. This now is a very important formula that you need to have down. Z is equal to your x score. I'm going to write that on this side. The x is our particular score minus the mean, which for a population is mu, divided by sigma, which is the standard deviation. If I were to use symbols from a sample, it would have been the score minus the mean of the sample, which would be x bar, divided by the sample standard deviation, S. All of these formulas basically are describing the same thing. this is probably the way it's written most often. We need to have that formula basically memorized, but be sure to copy it down in your notes once now. Now, let's take this particular concept and put it to use. If I take a look at this particular problem, I have a normal population, mean 70, so I'm going to draw the diagram. Mean of 70, standard deviation of 10. We've already done problems where we had to find the percentage of scores that were between 70 and 80. These tick marks represent standard deviations. Each standard deviation is worth 10. So this would be 70. This is 70 plus 10 or 80. Plus 10 more would be 90. Plus 10 more would be 100. 60, 50, and 40. We want the percentage of scores that are between 70 and 80. That means I want basically that percentage of that shaded area. You recall from the empirical rule, one each way was 68%. So this is half of that, or it would be 34%. Fairly straightforward problem. Using the z's to do this problem is going to appear like extra work now, but let me tell you why we're learning the procedure on these numbers. We are eventually looking at problems where they might say between 70 and 78. Well, 78 wouldn't be right at one of these. It would be smaller. It wouldn't be 34, it would be less than 34%. It would not be right on top of these standard deviations. Then the only method we can use is to use those z-scores. So if I'm looking for, I'm copying this off right up here now, the percentage of scores that are between 70 and 80. I am going to try and change those two z-scores. In other words, I'm going to change the 70 into a z-score and the 80 into a z-score. You remember that the z-scores were 0 in the middle for 70, and then one standard deviation was 1. The next one was a 2, a 3, and if I were going to the left, it would have been a -1, -2, and -3. Well, what is the z-score for the 80? It's obvious to see right here that it's a 1. But let's say it wasn't obvious, because if it were 78 or 79, it wouldn't be a nice integer 1. It might be something like 0.93 or some other unique number. How do I get this 1? Well, we get that by using that formula for the z. You just got done copying it down. It was your x-score minus the mean divided by the standard deviation. So for the 80, that 80 is my x-score. I'm going to put that in. Minus the mean, that's always the score right here in the middle, 70. Divided by the standard deviation, 10. In this particular problem, it was 10 over 10, and that becomes 1. So that's where that 1 shows up as. Now, let's find out how we would have gotten the 34%. This chart is in the back of your book. It's on page Appendix 30 in the back. You might want to put a marker there because you're going to be using that very, very often over the next few lessons. And you'll need that chart for the test. The chart starts up here, goes all the way down to a 3. I didn't get all of it copied here because it wouldn't fit on my screen. But if you look on page A30 in the back of your book, you'll see this chart. Notice the chart gives us percentages or decimal values from the middle out. So all of these numbers here in the middle of the chart are describing the percentage from the middle out. So this one right here, for example, would be about 35%. This one right here would be about 39.6 or maybe 40%. This one would have been 44. That means that shaded area would be 44. Okay, I'm going to come back to this in just a moment. Remember, we're trying to go from 1 back down to 0. In other words, I wanted to go from 0 to this 1. That's 1 standard deviation over. So I go to my Z and I go down here until I hit 1. That stands for my Z-score. Notice right there is the 34%. That's because it was 1.0. That would be 34%. So I would have gone to this chart and found that 34%, and that would have been my answer. Okay? Now, what happens if this had been a different number? Let's say, for example, it had been instead percentage of 70, and let's just go with 82. 82. Well, I would want to change that to Z-scores. The 70 would still be 0, but this 82 would be a different number. Rather than 80 in here, it would be 82 minus 70 divided by 10 rather than 80 minus 70. That means it would have been 12 over 10, or the Z would have been 1.2. Okay, now going back to my chart, I would have located 1.2, and it would have been 38.49% or 0.3849 because 1.20 has that probability. That probability by this left side is equal to the shaded portion. So it would have been 38.49, and that would have been my answer, 38.49%. Hopefully with this second example, when we don't get nice integers like 1, 2, and 3, but I might get some decimal, you see how we use that particular chart. Okay? We'll take some more examples like that in just a moment. Consider this one once. I realize you see the Z-score right there, but let's just imagine for a moment that we didn't. I want to change these to Z's. The picture would have looked like this. I had a mean of 140. Standard deviation at 25. 112 is on the left side. I don't know exactly where it is. I'm just going to put it right about there. 112 all the way up to 179, which is over here someplace. Again, I don't know exactly where it is, but I know that it's over there. I want the percentage of X's or scores that are between there. In other words, I want all of this shaded area as well as all of this shaded area on this side. I've got to find each of those parts. I do that by taking these numbers, 112 and 179, and changing them into Z-scores. This will be the same procedure we just got done with a moment ago. I've calculated some of these out, so hopefully this will go just a little bit faster here. But I'm going from 112, and I have a hard time finding that one, so I'm probably going to have to just do it right with you, which is probably just as well. So let's find the z-score for the 112. That formula was x minus the mean divided by the standard deviation. The x is your score, 112, minus the mean, which in this case is the 140, it's the number right in the middle, divided by the standard deviation, which was 25. So this z is going to have a negative 28 over 25. When I do that division, negative 28 divided by 25, I get 1.12, and it's a negative. So this 112 gets changed to a negative 1.12. Then I'm going to do the same thing with the 179. So I'm going to use the same formula. Instead of x, I'm going to put in 179. The mean is still the same 140 like it was earlier, and the standard deviation is still 25. This one is going to be 39 over 25. Well, if I take 39 divided by 25, I get 1.56. We always round our z's off to 2 decimal places. So 1.56. Now we're ready to go to the chart to find either one of these two sides. Let's find the one on the right first. That would be, I'll put this right up over here now, 1.56 is the z-score over here, 1.56. This z-score was 0. And the z-score, you recall, for that one there was a negative 1.12. The chart gives me from the middle out. So from 0 to 1.56. I'm going to go down here to 1.5. That's this row right here. Then I want 1.56. So I go up here to the 6.06. So I have 1.56 and I get 4406. That's this from the middle out, 4406. Then I also need to find from the middle back. The overall bell is symmetric on both sides, meaning it's the same on both sides. Not 4406 on both sides, but it means this negative 112 can be thought of as switching it over to the other side. So I'm going to find a positive 1.12. Here's 1, 1.1, and now row 2. So 1.12 is the 3686 right there. That's this side, 3686. So from the middle out to the left was 3686. I need to add to that on the right side, 0.4406. So my final answer, 6 and 6 makes 12. 8 carry the 1 was 9. 6 and 4 was 10. Carry the 1, I have 8. There's my answer for that. It was going to be 80.92%. Or if you wanted to, you could have wrote that as 0.8092. Those probabilities would go out 4 places. The z-scores we carry out 2 places. Again, that was an example showing when the z's aren't nice integers like a 1 or a 2 or a 3, then we're forced to use this chart. It is super, super important that you are able to master this chart. You will be using it frequently, and it's something that you absolutely have to be able to do to get through here. Okay? Let's have you try one now. I would like you to ignore the top one from 90 to 165. I would like you to work on this one right here. We're looking for the percentage of scores that are between 100 and 170. I have, in this case, the mean to be 140. So again, I would draw the picture. It makes it so much easier to keep things straight. The middle value is the mean at 140. I am looking for 100, which is somewhere over here on the left. It's not important that you put it in the exact spot. 170 is over here on the right. I'm again looking for the percentage of scores that are between there. So I'm looking for all of this percent as well as all of this percent. Very similar to what we had last time. So that means I'm just copying this down again now. 100, X, and 170. The first thing I got to do is change this to z-scores so that I can use that chart. I do that again by that same formula for the z. That formula was the x-score minus the mean over the standard deviation. The standard deviation up here was 25. So for this 100, that's my x-score, minus the mean, which is 140, divided by the standard deviation, 25. That gives me a negative 40 over 25. Many of you can do that in your head, but if not, you are looking at 40 divided by 25. Turns out to be 1.6. But notice it's on the left side, so that makes it a negative 1.6. Now I need to get the z-score for the 170. Same formula. Z is going to be my x-score. This time it's 170. Last time it was 100. So it's 170 minus the mean. The mean is still 140 in this problem, divided by the same standard deviation. This time I get 30 over 25. So I find that on my calculator. And I get 1.2. Both of these z-scores happen to come out to just 1/10. If they hadn't, I would have rounded to the nearest 100th, 2 places. But I didn't have to in this case. But now I'm ready to go to my chart. So I put the chart up, and I'm looking for these 2 z-scores. I'll actually put them right over here so we can see them. Let's take the left side first. It corresponds with the z of 1.6. Right here is 1.6. It's 1.60 in that column. So that's 4452. Or I could say 0.4452. The right side corresponds with 1.2. So I find 1.2, which is then 0.3849. I will need to add those together. 0.4452 plus 0.3849. When I add them together, I'm going to get 11, 10, 13, and 8, I believe. So I have 0.8301 or 83.01%. That was again an example, very similar to the previous one, to help us use that chart. Let's take one more. You could practice these if you wanted to, but let's take just one of these and grind it through. I'm going to try and pick one that is just a little bit more challenging. Let's pick, in this particular case, the last one. I have a normal distribution, mean 180. So I'm looking at this last one right here. I'm going to draw the picture, big bell curve. The middle value again, what is it? It's the mean, 180. Standard deviation given to be 30. We want from 160 to 170. 160 is over here someplace on the left, 170 not as far. I want the percentage of x's that are between there. In other words, I want that shaded region. I'm needing now to be able to change these x scores. I've got to change them into z-scores. Same old formula. Z is equal to x minus mu over sigma. My x score for this one is 160 minus the mean 180 over the standard deviation 30. I end up with a negative 20 over 30. You can probably do that one in your head. It's going to be a negative 0.67 when you round it off. Now I need to change 170 into a z-score. I'll go a little further over here. So rather than 160, I'm going to be using 170 minus 180 again, divided by 30. This time, it's a negative 10 over 30. That would be a negative 0.33, rounded off. So far, everything I've done is very similar to what we've done previously. But now it's kind of a tricky spot. The 0.67 on the chart is going to give me all of that, because that's the z-score that corresponds with 160. The 0.33 is going to give me this spot right there. I need to get the total from 160 to 180 and then subtract this unshaded part. The total from 160 to 180 corresponds to the z of 67. So let's get that once. 0.67, here's the column for that. That would be 0.2486. So that's the larger one, 0.2486. Now let's get the percentage right in here. It would correspond with the 0.33. Here's 0.3. 3 would be 1293. This 2486 would be accurate if it were all shaded. But because this portion is not shaded, I need not to add these two this time like I did previously, but I got to subtract this unshaded part. So my final answer is going to be this 2486 subtracting 1293. So when I do that subtraction, I'm going to have the following value, 0.1193. That's this shaded area, 0.1193. tougher problem because we had to subtract in that case. Here is an example now, what we call going the other way. Going the other way. This is where, like we did earlier, about 15 minutes ago, finding a score. Okay, so to do that, I'll keep it covered here for the first part. I have a normal distribution. Mean of 80, standard deviation of 15. I'm going to be looking for a number on the bottom here, something like 80 or 81 or 82 or 83 or 79 or 78 or something like that. We're going to call that score C. That's what we're looking for. We could have called it X, but we're going to use C here. I want to find a score that is above 75% of the other scores. Well, would you agree 80 is above 50% of the other scores? If I want it to be above 75%, I need 50 and another 25% of the scores. This score would be above then all of that 50 and 25 together, which makes the 75. I need that score, which we're calling C. We need to work that Z table backwards. Remember that the table goes from the middle out. In other words, from the middle out here is 0.25. I need to look for that number in the middle of the chart, 0.25. In other words, I'm looking somewhere in the middle for 0.25. Once in a while it'll be exact, but most of the time not. So I'm going to pick the closest one. For example, 0.2486, 0.2517. This one's too big. This one's too small. This one, though, actually is closer. It's about 0.0014 away. This one is 0.0017 away. So 0.25 is closer to that one, which means that's the one I'm going to pick. It's the closest one. So what is that Z-score? It is 0.67. The Z-score that corresponds with 25%, the Z-score is 0.67. It's not my C yet. It's the Z-score. To get my actual score, we had a formula up here. We're calling that score now C. That formula, you remember, was the mean plus my Z-score, which we just found, times the standard deviation. So the mean was 80. The Z-score is 0.67. The standard deviation is 15. If I had a fraction there, it would come out a little bit even, a little bit more even, but I'm going to act like I'll go with the decimal. So I'm going to take 0.67, multiply it times 15, and I get 10.05. 80 plus 10.05. So that C is going to be 80 plus that, or 90.05. That's this C score. That 90.05 is above 75% of the other scores. That 90.05 is above all these 75% of the other scores. Okay? Let's put this now into a word problem format. You will get some of these on your assignment, but certainly you can anticipate some of these on your test. We're going to look at two different word problems. This one is asking for what percent. The second one is going to be asking for that score, like we just called a C. So these are the two methods, but in a word problem format. So let's take a look at this one once. The mean weight of the cereal boxes is 21, standard deviation 0.3. It says that it's normally distributed. That means that I can draw that bell curve. So I'm drawing the picture again. The mean is 21, standard deviation 0.3. We want the percentage of the boxes that will weigh less than 20.5. Well, let's take that 20.5, but everybody agree that's less than 21, somewhere here on the left. I don't know exactly where, but somewhere on the left. So I'm going to put it out there. I want the percentage that are less than that. So really what I want is this shaded portion. Okay. If this had been given in the previous format, we would have said the percentage of scores, the percentage of X's that are less than 20.5. I need to change that to a Z-score. Same old formula for the Z's. It's going to be the X minus the mean divided by the standard deviation. The X is 20.5 minus the mean 21 divided by 0.3. That's going to be a negative 0.5 divided by 0.3. That's Z-score. Then it's going to be a negative 1.67 when you round it off to two places. That means the Z-score below this number is a negative 1.67. It's negative because it's on the left side. Remember the chart again. Gives you from the middle out. So the chart is going to give me this unshaded portion. That unshaded portion will be found by looking up this Z-score, 1.67. So here we go, finding that 1.6, column 7, 1.67, it's this 45.25. It's 1.6 and the 7, 45.25, but that's from the middle out. So that's from the middle out, 45, excuse me, I wrote that wrong. 45.25, I believe. I better double check that. Yeah. This portion then is found by recognizing the entire half is 50%. And I'm going to subtract this unshaded part, 45.25%. I could have put those all as decimals. 0.5 minus 0.4525. When I do that subtraction, I'm going to have 5, 7, 4, 0. And that's going to be my final answer, 475. If I listed it as a percentage, it would be 4.75%. That's what they wanted me to list it as. So that would have been my answer for that one there. A repeat with B, one of the numbers is the same, but I have a different number in there as well. It's the same bell curve, the same mean of 21, 20.05 is on the left here, 21.4 is on the right. This time, I want this percentage and this one put together between those two numbers. I'm looking for the percentage that's between 20.5, it's an X score, and 21.4. The first thing I got to do is change these to Z scores. The 20.5 we did over here. So if you don't mind, I'm just going to use that same number. I could have found it with that same formula, but a negative 1.67. Let's just show where the 21.4, what that z-score. This z-score was a negative 1.67 again. Let's get the z-score for that one. That z formula, again, just like it was over here, x minus mu over sigma. So my x is 21.4 minus 21 over 0.3. That's 0.4 over 0.3. That's 1.33 when you round it off. That's the z-score that corresponds with that 21. So I need to look up 1.33 in the chart. If I do that, again, that chart is on A30 in the back of your book. But 1.33, here's the column 0.03, 1.3 is this 0.4082. So I'm going to write that 0.4082 in there. That represents this part, 0.4082. I'll put that down here. 0.4082, I'll write it a little bit clearer. Sorry about that, I'm still learning this medium. This one, you remember, came from over here as well. It was that 0.4525, but if you didn't remember that, let's find it again, 1.67. Here's 1.6, column 7, 0.4525. That's from the middle out, 0.4525. This time I'm not subtracting it, but these two need to be put together, so I'm going to be adding those. So 5 and 2 makes 7, 2 and 8 makes 10, carry the 1, get 6 and 8. 0.8607 is the probability that it's between those two numbers, or we can say 86.07% is between those two numbers. Both of these examples, we found a percent. I didn't change this one yet. 86.07% is my answer. Now I'm going to go the other way for our last example. I have exam scores that are normally distributed. Normal means they make a bell curve. So I'm going to draw the picture. Bell curve. It's got a mean of 83. Standard deviation of 5. I want what score, notice it's not a percentage or probability, it's a score. It's some score like 83, 82, or 81.5, 81.9, something like that. I want a score, we're going to call it C again, to be in the bottom 20%. Well, the bottom 20% would mean this is the bottom 20% there. I'm looking for that score, which we're calling C. Do you remember that the chart works from the middle out? So I need to work from the middle out, this part. I know that it's half or 50 all the way. If 20 is here, that means 30, because 30 and 20 make the whole half of 50. I need to work with the 30 in the chart. I've got to find the z-score that goes with the 30 in the middle. The 30 is found in the middle someplace. The closest one is between these two. 0.2995, 0.3023, that's closest to 0.3 or 30. This one happens to be closer. So it's a z-score of 0.84. That's my z-score, but it's on the left side, negative 0.84. That's my z-score. Now I find my actual score, the C. You remember that formula for the score? We saw it earlier today. It was the mean plus a z-score multiplied times the standard deviation. So the mean is 83. The z-score we just found to be a negative 0.84. The standard deviation was 5. That means that I'm going to multiply this. I get 2042. This would end up to be 4.2 when I put the decimal in, and it's a negative. So it's 83, didn't write that very plain maybe, minus 4.2. If you take 83 minus 4.2, I believe you get 78.8, but you can double check me on that. That's my score. Notice it's smaller than 83. It's on the left side like we would anticipate. Notice that I had to find the z-score and I had to use 30 and not 20. Even though the problem had 20 in it, I had to recognize I needed to go from the middle out. That was an example finding the score. This one is similar, but it works on the other side. So again, top 25%. I draw my bell. The mean is still the same, 83. Standard deviation still 5. I want the top 25%. Top is on the right here, 0.25. This time, half of the 50 is 25. Both of these have to be 25. Last time they were different, 20 and 30. To make 50, they both had to be 25. I'm looking for that score. I need to find from the 25 in the middle of my chart. So I look for that in the middle, 0.25. The closest one is right here. Again, we used that one earlier, 0.67. So the z-score happens to be 0.67. I'm going to now go with the same formula right over here. C is equal to the mean plus the z-score we just found times the standard deviation. So the mean is 83. Z-score is 0.67 times the 5. I'm going to do that on my calculator if you don't mind. 0.67 times 5 is 3.35 plus the 83, that's going to be 86.35. That's my score. Notice again, it's on the right side, greater than 83, which we would anticipate. This one was on the left side, and it's because my z-score, which I had to turn to negative because that was on the left side. Drawing these pictures helps you keep that straight in a much higher level, okay? That is the end of our lesson here today. I'm assigning 4.3. It will be due 2 class periods, so it's going to be due the following Tuesday. Let me just get my bearings straight here. I think it would be March 31. So I'm assigning here 4.4 due March 31. Gives you about a full week to do that. There'll be a drop box, just like we've had previously. So you complete your assignment, 4.4, take a readable picture, make sure your name is on and everything else, put it in the drop box for section 4.4, and then we'll see you for the next class.